All right, we'll go ahead and get started. My name is Gigi Hatfield with Protect Services Group, and I'd like to welcome everyone today to our webinar, joint webinar with Protect Services Group and the Sero Group. Before we get started and turn things over to Joe Webb with the Sero Group, I'm going to open it up for Chris Bradley to talk a little bit about Protect Services.
You don't want to join us, do you? Something about SQL Protect.
At this time, I'll turn it over to Chris Bradley.
Thanks, Gigi. Hey, Joe, could you get to the next slide, please? So good afternoon, everyone, and welcome to our webinar, Striving for 5 9's, Creating a Highly Available SQL Server. My name is Chris, and I'm the VP of Managing Cloud Solutions here at Protect. And before we dive into today's topic, I want to take a moment to introduce Protect to those of you who may not already be familiar with us. Protect Services Group is a technology services firm with 29 years of experience focused on understanding the technology needs of businesses and applying a range of innovative solutions designed to help drive them forward. With a wide range of services and solutions, some of our core areas of expertise include managed services ranging from fully outsourced IT operations to custom services designed to meet specific customer needs. Cloud solutions from infrastructure as a service from large public cloud providers such as AWS and Azure to enterprise cloud and a variety of SaaS solutions. Security solutions, including our managed security stack, utilizing a layered approach to protecting IT and data assets, compliance SIM and SOC services to security awareness training and testing. Carrier and voice services, providing consultative analysis and cost optimization for internet and telecom services, premise-based phone solutions, and cloud-hosted voice and call center solutions. Technology and consulting services, which range from small to large-scale IT projects to consultative engagements in any of our areas of expertise. Talent acquisition, with a full-featured staffing division, we are able to assist with temporary and permanent placement of resources with talents ranging from IT and finance to the executive level. Lastly, Protect prides itself in being an integral part of the community through its Protect Cares initiatives, supporting organizations like the Boys and Girls Clubs of Memphis, Streets Ministries, St. Jude, and the National Civil Rights Museum, to name a few. It is within our core values to be a true technology partner and help organizations leverage technology to achieve profitability, growth, and security. So today we're excited to be with Joe Webb with the Sero Group to discuss creating a highly available SQL Server. Joe, take it away.
All right, thank you very much. Let's see, today we would like to talk about striving for 5 9's, creating a highly effective or a highly available SQL Server environment for your business operations. Many organizations are becoming much more reliant on critical data systems for their day-to-day operations. Healthcare systems or healthcare organizations rely on EMR and EHR systems. They rely on practice management systems. Other companies, service companies, rely on scheduling software and transportation, legal, banking, import, export, construction, you name it, all have critical components that reside in inside of SQL Server. We have customers in all of those different industries. And any time there's a disruption in a SQL Server environment, it propagates out and affects business operations. Customers, stakeholders, employees have difficulties doing their jobs if there's a disruption in that data system. And so what we'll talk about today is how we can minimize that or potentially even eliminate any sort of downtime in your Microsoft SQL Server environment. So, not going to go through this in a lot of detail. I've been a part of the SQL Server community for quite some time. I've spent the last 24 years doing Microsoft SQL Server consulting. Started way back on version 6.5 back in the late 90s. Worked with a lot of different organizations, both internationally and here in the U.S. as part of it, and was awarded 8 times the Microsoft MVP award. Enjoy sharing webinars and in-person conferences if we ever, kind of get back to that. But for now, what I'd like to do is just focus on this webinar and share some of the experiences that I've had in creating highly available systems. So at the Sero Group, what we do is we provide essentially database services to our customers. We provide DBA as a service. We focus on customers that organizations that may not have the need for a full-time database administrator, but they have that critical information inside of a SQL Server. So they need it to be up and running all the time. They need it to be performant, secure, reliable, but they just don't have either the budget or the need for a full-time DBA. And so we provide those type services, a lot of different industries. Of course, we do consulting, and we do some other services that are around the SQL Server space as well. So today, I'd love to hear what you would like out of today's session. I've got some things that I would like to cover, but if there's something specific that you would like to talk through, or if you have questions along the way, I'd love if you would just open up the chat window inside of Microsoft Teams and maybe jot down a short note in there. If it's a question, we'll take that towards the end of the presentation. But if we can get to it during the mid-presentation, we will, but usually towards the end of the presentation. So if there's something specific you would love to talk about today, feel free to put that in the chat session. What I plan to talk about is essentially why SQL Server, or why high availability and disaster recovery is important for organizations. The capabilities that SQL Server has for high availability and disaster recovery, and then putting it all together. Let's start by really talking about what we mean by 5 nines. It's a term that I think a lot of people probably have heard. It essentially means when you look at the percentage of uptime for a system on an annual basis, what percentage of the time is it actually up and running and functional? So 1 9 is considered 90% availability. 90% in a lot of other situations is great. 90% from a data system is actually pretty bad. 90% uptime means that out of a year, we will have 36 days of time when there is no availability in the system. 2 nines of availability, which is 99% uptime, means that we have about 3.5 days worth of time where that system is unavailable. 3 nines, we're still looking at a full day and 8.8 hours worth of unavailability. 4 nines is still almost an hour in a year that it's not available. And then 5 nines, we're really getting down to just the minutes level now. We're talking about 5 or 6 minutes worth of downtime. Now, obviously going from 3 nines to 4 nines to 5 nines is a very challenging thing to do. So we'll take a look at how we could take steps towards that. But just to put it in context, if your system has maybe a 2-hour scheduled maintenance window once a quarter, so 8 hours a year, you're looking at roughly 3 nines of availability for within your system. So we all know that unplanned or even planned downtime can be very, very costly. Gartner in 2014, which is fairly dated now, estimated that it cost an average organization roughly $5,600 per minute. In a slightly newer survey, it was calculated at almost $9,000 per minute. That includes the idle time of employees, the cost of new orders coming in, the lost business that can't come in, or that you have offended or let your customers down and they go someplace else. My hometown is Nashville, Tennessee. Live just outside of Nashville, Tennessee, and not terribly long ago, 6 months ago, we had a disruptive event downtown. on Christmas Day that took out the AT&T building's connectivity to the internet. So throughout all of Middle Tennessee, 911 was unavailable. It affected both landlines, internet access, and their Wi-Fi capabilities. So it took down cell phone coverage. I've talked to organizations that because of that, they had relied on AT&T as their landline or their land connectivity, and their backup plan was AT&T wireless. Now they're looking at spreading that out so that they can go with different organizations to provide that redundancy for them. So unplanned downtime can cost an organization a tremendous amount of money. What we're looking at within the SQL Server world is to figure out how we can continue business operations, even if there is some sort of disruption to the normal flow of business. We're looking at creating a business continuity plan for within the SQL Server space. And so at a high level, we're looking at high availability and disaster recovery. As a working definition, the difference between high availability and disaster recovery is if we want to minimize or even prevent any scheduled or unscheduled downtime for our SQL Server environment. So if we need to do a planned maintenance, we would like to not have to bring the system down. If we're going to update or upgrade our systems, if we're going to if there's a disruptive event within the SQL Server stack, we want to be able to have that those services transfer to another system so that there is no disruption in service. Disaster recovery, on the other hand, is if there is a disruptive event in the SQL Server space, we want to be able to recover quickly. How fast can we get from being down, a catastrophic event, to back up and running again? So with disaster recovery, we're talking about things like hardware failure, corruption of databases, recovery from user error within the application. If someone has accidentally deleted tables, deleted files, deleted key account information within SQL Server, or something much broader, things such as system-wide problems, ransomware, tornadoes, hurricanes, fires, things that could affect your entire data operations, your data centers. From a high availability perspective, we're looking at things that are much more specific to SQL Server itself. We're looking at keeping your practice management system up and running, your EHR, EMR systems up and running, your financial, your customer portal information. All of those we want to keep up and running if there's some sort of hiccup in a disruptive event that occurs. So let's look at how SQL Server can actually do that. What does it has built in? The first question you want to ask when considering some sort of high availability or disaster recovery plan is, how were your operations? How will your customers? How will your stakeholders? How will your employees? How will senior management be affected should something happen to your data system? From that, you'll be able to identify what your recovery time objectives are and what your recovery point objectives are. So how long can you be down without an adverse effect? And at what point should you be able to recover? So if something happens at 2:30 in the afternoon, do you need to be able to recover to 2:29? Do you need to be able to recover to sometime since the last full backup at midnight, somewhere in between? At what point, how much data is acceptable for you to lose? And frequently, when we began talking with having these conversations, the first response is, well, we don't want to lose any data and we don't want to be down at all. However, those practices do come with a cost. It can be done, but it does come with a cost. And so finding that balance is key. So understanding the requirements of the business is going to be the first and most important component for implementing your HADR. So within the SQL Server world, we have really 4 options that I'd like to talk about today. I'm not going to spend a whole lot of time talking about the first 2, backup and restore, and then log shipping. The second 2 are going to be much more interesting to talk about, and will have a lot of applicability for keeping your systems up and running all the time. So a standard backup and restore, that is the blocking and tackling. That is the core fundamental and foundational aspects of keeping a good database server available. You want to be able to, you want to create a system where you can not only back up, but then recover in a manner that allows you to satisfy your RTOs and your RPOs. So we typically recommend doing full backups on a periodic basis, doing differential backups, and then doing transaction log backups on a scheduled basis. You can also throw in the mix of some other virtual machine snapshots, things like that, to help out. But certainly you want to make sure that you have a plan for recovering, a recovery plan for if something goes sideways. Now, we recommend using the Microsoft native SQL Server backups. We typically recommend having a local file system on which to store these backups, and then use another archival process that will take those local backups and copy those off premises, or at least to another system somewhere else. So we typically recommend having a backup to a local drive, and then having those copied off for archival and posterity purposes. You want to periodically test your restores. You want to make sure that you do have the capability to restore should SQL Server have an issue. The nice part about backups is they're built into SQL Server. You just have to turn them on, and once you set them up, they typically work without a lot of intervention. I would encourage you to test them along the way, though. So it's inexpensive. The downside is if you have to restore, it's a manual restoration process. So you're going to have someone that is going to be available to respond to that catastrophic event. It does not provide any sort of benefit for high availability. Log shipping is a way, is kind of like the next level up from standard backup procedures. With log shipping, essentially what we're doing is we have a standby server, a standby SQL server that is that has a backed up copy of the important databases from your primary server. And what will happen on a periodic basis, usually every 5, 10, 15 minutes, all transactions that were recorded in the primary system are backed up through the transaction log. Those logs are copied over to that warm standby server and then restored into that standby server. So what that allows is that if there is a problem with your SQL Server, the system crashes, there's something that happens, the VM goes down, the host goes down, and if that warm standby server is still available, then someone can go through and convert that standby server into the primary server as the methodology for recovering. So It's nice. It's been around for a long time. It's been proven to be a very solid implementation and a very solid solution. Unfortunately, though, it does still require manual intervention. When your front-end applications, will need to be pointed to that new server. So you may have to change some connection strings. You may have to change reporting environments and everything else that depend on that connection to the SQL Server. It'll have to be manually moved over to point to the new standby server if it does become primary. Because this is done on a periodic basis, 5, 10, 15 minutes, there exists the possibility of some level of data loss. So if you are doing log shipping every 15 minutes and 14 minutes into that period, the system crashes, you may lose up to 15 minutes worth of critical data in your application. Now, let's talk a little bit then about always-on failover clustered instances, FCIs. Essentially, what an FCI is you could think of it as one Microsoft SQL Server instance. That one instance is installed inside a Windows Server failover cluster. So it's spread across multiple Windows environments, multiple Windows servers. And if any one of those Windows environments has an issue, then what will happen is the primary Windows server, if it goes down, services are automatically transferred over to the secondary node, to a secondary node. And so what will happen is if you've got server A is primary and you've got server B as a secondary node, server B is just sitting there waiting for server A to fail, whether it fails on because of a scheduled maintenance or if it fails because of a disruptive event. Server B is sitting there waiting for server A to fail. When that failure occurs, then automatically services are stopped on that primary node, services are started on that secondary node, and the clients are now redirected over to that secondary node. The way it's implemented is it requires some shared storage. So you may have a network SAN or another piece of hardware that provides that storage, and the primary Windows server will have ownership of that resource. And as long as it has ownership of that resource, it's going to be answering those questions. It's going to that SQL Server will be responding on that primary node. When a failure occurs and it's transferred over to a secondary node, the first thing that happens is that shared storage gets transferred from the primary Windows node to the secondary Windows node. SQL Server is started on that secondary node, and then those databases are brought back online and through a recovery system. So SQL Server, when if it's a scheduled or maintenance window, or if it's scheduled to be down, what will happen is it can take a few minutes, perhaps a certain amount of time for SQL Server to write all of those all of those buffers, the information in memory, to the shared disk, and then will allow the secondary server to come back up. So typically you're looking at a very short amount of time, depending on how busy the system is and how active, how many transactions are going and how long those transactions are. It could be noticeable to your users. Often it is not, but it could be noticeable to your users. If it's an unscheduled downtime, meaning the primary node just simply fails for whatever reason, a secondary node will pick up that responsibility and go through its normal recovery process, which again could take a certain amount of time for it to verify that all the transactions are either in the database itself or will be rolled forward. So it does provide excellent operating system level redundancy. It does not require additional services or additional SQL Server licenses. It's available on Standard and Enterprise Edition. Since you only have one SQL Server instance running at a time, in fact, the SQL Server services on the secondary systems are not even running at all if the primary server is running. It does not require those additional licenses. The downside is it does require shared storage or at least the ability for replicating the data across the network to another shared storage device. One last thing on FCIs. When a SQL Server, when a client connects to the SQL Server, it's actually connecting to a virtual network name so that the clients do not need to know which SQL Server instance is the primary, which node of the Windows cluster is primary. It will follow the primary node of the cluster. And so clients are completely unaware that server A is responding now and server B responded yesterday. Our next option is always on availability groups. Availability groups were introduced a few versions ago in Microsoft SQL Server and really come in a couple of different flavors. Availability groups provide database level redundancy as opposed to instance level redundancy provided by failover clustered instances. In database level redundancy, essentially what we're looking at is we have a Windows Server failover clustered instance, and you can have multiple servers that are participating in this cluster, and one of those servers will be the primary server for a handful of those databases. We call it a replica. It'll have the primary replica of those databases. When queries come in from clients, the clients will connect to a listener that will direct the queries to the primary replica. And that primary replica will respond to those queries and will be the replica that gets updated. Periodically, what will happen is those transactions, any changes on that primary replica, will be propagated over to the secondary, all secondary replicas. And so we can have one or more secondary replicas that are just standing by waiting for the primary to fail. Unlike with FCIs, these secondary replicas are actually running SQL Server all the time. They do not require any sort of shared storage that is available to all of the replicas. They each have their own copy of those databases. And so if any one of those databases in the availability group fails on the primary replica, all services will be shifted over to a secondary replica, and the listener will begin pointing those queries and transactions to that new primary replica. The nice part about availability groups is that since those transactions are being sent on a scheduled and regular basis, either asynchronously or synchronously, depending on how you have them configured, they are up to, those secondary replicas are up to date, particularly if you're in a synchronous mode. They stay up to date, so there will not be any data loss if the primary replica goes down unexpectedly. It could, just like FCIs, availability groups can be used for scheduled maintenance as well. You can use, apply Windows and or SQL Server level patching to one instance, fail over to that instance, and then apply it to the first instance. And so you can reduce or even eliminate your downtime associated with scheduled maintenance as well. The downside to availability groups is, although SQL Server Standard Edition technically allows for availability groups, it's what they call basic availability groups. And in basic availability groups, you're limited to just one secondary replica, and you can only fail over one database as a group. And so under certain circumstances, that may be enough, but if you need to fail over multiple and you would like to broaden your availability beyond just 2 servers, you'll end up needing to go with Enterprise Edition, which, as I'm sure you're aware, can become pretty expensive, particularly if they're large servers. Let's see. Steve asked, on availability groups after a failure is resolved, when and how does it go back to the primary? Good question. So there are a couple of different ways that we can configure SQL Server in the availability groups. We can configure it with synchronous or asynchronous failover. And within the synchronous world, it will happen. It can be scheduled to happen automatically, or you can say that it's synchronous with manual failover only. So essentially what that means is, in a synchronous world, every transaction that comes into the primary instance, the primary replica, that transaction is not committed until all secondary replicas that are synchronized with it also commit it to their log file. And so within a data center, synchronous replication makes a lot of sense. You minimize any data loss, but at the cost of potentially lengthening the time it takes for each transaction to commit. So you may experience a little more of a performance penalty associated with synchronized replication to the replicas. With synchronized, you can either tell it to switch automatically anytime that there's a failover, and so whether it's planned or unplanned, it'll automatically flip over, and then you can go in and flip it back to the primary to a different primary if you wish. With the planned mode, then it only fails over when you go in and manually do that. For asynchronous commit modes, that replication is done on a scheduled basis. It's something a little bit like log shipping. It's not quite the same, but it's similar to log shipping. That's frequently done if you're using availability groups in a distributed environment. So if you want to, for example, have one replica in a data center in Memphis and another replica in a data center in Atlanta, you could do that, but since there may be a certain amount of network lag or latency that is introduced then. You may not want, for performance reasons, you may not want to put that on synchronous mode. You may want to put it on asynchronous mode, with the understanding that there could be a small amount of data loss if a failover needs to happen. So from a high level, then let's compare FCIs and availability groups. From a licensing perspective, a single license is good for FCIs because you're only running one SQL Server instance at a time, even though it may be spread across multiple Windows servers in a cluster. Availability groups is the same if you have software assurance. The secondary replicas typically do not require their own licenses. You can make readable secondary replicas so that you can offload some maintenance tasks to those secondary replicas. For example, you may want to offload backups to the secondary replica, or maybe even some complex reporting to that secondary replica. So your primary replica becomes the avenue for your primary operations, but maybe some dashboard reporting is based off that secondary replica. If you do that or use it for maintenance, it becomes a production system as far as Microsoft is concerned, and you must license that secondary replica. FCIs are available on standard and enterprise. The same is true for availability groups, but in standard edition, it is only the basic availability groups, limited to one secondary replica and one database per availability group. There's no storage requirements for specific storage requirements for AGs, where we must have shared storage for FCIs. That could be a limiting factor for you. The other way to think about that, though, is that for each secondary replica you have within your AG world, it's getting its own copy. So if you have one secondary replica and your primary replica, you've essentially doubled your storage space requirements. If you have 4 secondary replicas, you've multiplied your storage space by a factor of 4 compared to your original. Protection. The FCIs run at a instance level, which is nice because that means all logins, all user accounts in the databases, all maintenance jobs, everything fails over from one instance to the other. Within AGs, that's not the case. You are failing over specific databases, and those logins that the databases may depend on, those scheduled jobs that the databases that your operations may depend on, do not fail over with the availability group. So care has to be taken on an ongoing basis to make sure that all of those ancillary things, the instance level things that your databases may depend on, get migrated every time there's a change on the primary. It gets migrated to the secondary. As an example, there may be scheduled jobs that run on the primary that do not need to run on the secondary. And so typically what we do is we have a script that we include as the first step on every single job that says, hey, am I primary? If not, abort, don't do anything. But if I am primary, go ahead and do these maintenance tasks. FCIs, like standard backups and log shipping, are typically done as a disaster recovery environment. Can be done as a disaster recovery environment, but they are primarily considered high availability. With the availability groups, you can configure those for either high availability, or disaster recovery. The nice part about both of these options are that both of them can reduce downtime that your users will experience for planned and unplanned events. So briefly, let's put it all together, and then we'll open it up to the Q&A. Regardless of what you're doing, all of these techniques, I would encourage you to use backups and restore. Have a restore plan. Backups are great, but unless you know how to restore from those backups, it's not really worthwhile. So you need to be able to know how to restore. You need to be able to back up your databases on a periodic basis. That's just considered a disaster recovery. Log shipping can expedite that. Creates essentially a warm standby server that can be used for DR purposes. Failover clustered instances, although it can be used for DR, primarily it's used in the high availability world for an instance of SQL Server. And availability groups is primarily a high availability, though it can be used with DR capabilities as well. As you're going through this, I can't emphasize enough that it should be part of a broader HADR conversation within your organization. This is just one component that can participate in that broader context of HADR. So if you have multiple data centers and you're using some sort of push button DR capabilities, that's phenomenal. Figure out how SQL Server's approach to this is going to play into that. As you get started, I would encourage you to, at the beginning, assess where you're starting with your SQL Server. Confirm that you're having backups that are occurring on a regular basis, that you have the best practices implemented for where your log files are, your data files are, your operating system files are. Make sure that they're all separated. Your TempDB has its own set of disks as well. Make sure your SQL Server can communicate with you if things begin to go sideways, if jobs fail, if standard events happen. SQL Server needs to be able to notify you by email. So you want to make sure that you're doing those things, even if you're not at a point where HA and DR becomes an option for you. All right. What questions do you have? That was a very, very high level overview of some of the HA capabilities of SQL Server. What questions do you have? As we're waiting for those to come in, I don't want to discourage you from typing. I do have some references, additional resources that may be of interest to you. Do have what's the difference in SQL Server FCIs and AGs, and where to start with disaster recovery in SQL Server. Microsoft has some very good documentation on their website, including some detailed how-tos, and so those are available for you to take a look at as well at these links. And if you would like, I'll be happy to share this slide deck with you. Just shoot me an email. There's my email address, and just shoot me an email, and I'll be glad to hand the deck over to you.
I did have a few questions, if it's okay to ask.
Absolutely.
Yeah. With virtualization and these other abilities to do other things, to kind of, I guess having more options is not bad, but it kind of muddies up the water on where to go, what to choose. So I currently have, a SQL cluster with two physical blades, which is working fine. But I would like to rethink some things because I do have a pretty hefty virtual environment we've invested in. It makes more sense to me to possibly look at it, finding up I do have SQL servers virtualized, but not on a smaller scale. But the cluster one, why not just make it virtual? What about I have Zerto. Why not take advantage of Zerto? And I know that muddies the water and kind of, or should I, if I virtualize it, should I even consider clustering it also at the same time? Once you virtualize it, it kind of has ability to fill over to different hosts. I know I'm speaking in broad terms, but it's like you have all these choices, which is a good thing, but you just want to make sure you're always making the right choice when you mix it with other technology. It sounds to me like maybe I just need log shipping. Virtualize it, maybe make it clustered so I can do updates maybe back and forth, and I know it's hard to say because it's all personal depending on your needs. Everybody has different needs. But
I'm so glad you brought that up. Yes, there are other technologies that exist outside the SQL Server space that can be used to help with HA and DR. Virtualization, you can use VMotion, for example, to move a SQL Server instance from one to another. All of that sort of stuff can be done. And that, since it is a broader context than just SQL Server, the discussion about how to create a highly available environment for your SQL Server needs to be held within that context of the broader HADR discussions for your environment, right? Now, having said that, a lot of companies will use a combination of those technologies that exist outside of SQL Server and SQL Server itself, log shipping or something else, in combination to accomplish different things. So, for example, in your case, absolutely, you could use something like VMotion to go, to move it across. So if you have to do, update one host, even you can VMotion it across and update the host. One of the benefits of FCI or availability groups is that you can significantly minimize any downtime associated with applying Windows updates or SQL Server updates.
Right.
And so, in a lot of environments that run 50 hours a week and they have every weekend off and nobody uses it from, 6 p.m. to 6 a.m., that sort of thing, maintenance windows are not a big deal. You don't need availability groups or FCS for that, perhaps. A lot of our customers, though, say hospitals, or if they have an online portal that their customers or clients are using, they have to be up all the time. And so maintenance windows can be done, but they need to be as short as possible and as infrequent as possible. Right. And for them, then, perhaps for them, what we've done is either FCI or AGs, depending on a number of other factors.
Well, FCIs seem to take care of the hardware issues and also the update issues. But, I also want to be sure that I don't have database corruptions, which, of course, your backups take care of that. But, maybe a product like Zerto can make you be able to go back in time even more increments. I don't know. Because not only do you want to, the FCIs and the AGs I don't know if AGs help on corruption either. Because if you're got a corrupt database and you're replicating it, well, you're replicating your corruption.
The same is true for backups.
That too. You're backing up. Yeah, true.
You're backing up a corrupted database, which is why I would highly encourage you, not you, yes, but everybody, to on a scheduled basis, ensure that those backups can be restored and then run a check DB against all of the databases that you are doing your test restore on. It gives you the ability to, yes, prove to yourself that the backups are good, that there is no database corruption that was introduced as part of that process. And then also it just gives you practice, right? You know, you're proving out your documentation.
Certainly. Okay. I ask one more question, and it's just something that interested me what you said. Out of the box, by the way, I am backing up my cluster using the native, backup to a storage area that I eventually back up with my backup software. Mm-hmm. But my backup software also has SQL agents, and some SQL servers, the virtualized ones, I am using the SQL agent. Mm-hmm. But I do notice a lot of DBAs and a lot of people that work with SQL prefer the plain old data dumps, I guess is what you mm-hmm. want to call them. I didn't know your opinion on that. I mean,
I fall in that category as well. We generally recommend using the native SQL Server backups mm-hmm. and not an agent like Commvault or some of these others that are available mm-hmm. that use an agent to go down inside of SQL Server to do those backups. Mm-hmm. We've seen issues with those either through performance or recoverability with those. And just generally speaking, the ones that are built into Microsoft SQL Server, the native ones, just typically perform better and are, more integrated into the process. So yeah, okay. I definitely fall into the category of use native unless you have just a very compelling reason to go, outside of that. We typically implement, if you're familiar with Ola Hologren's scripts, mm-hmm. great. I'll be glad to send you the link to that. It's got some great scripts that are available for free. It will use some of the other components, some plugins, if you want to use some of the other tools that can be used to enhance compression and some other things.
Well, and in previous deployments, not where I work now, but where I've worked in the past, they used something called Lightspeed, and it was kind of almost, I would say, magical when it compressed and how fast it backed up. I don't know what it was doing. I'm sure it was compression and something behind the scenes.
Typically, if you have CPU available, compression makes a lot of sense because it can compress, and the limiting factor on most backups is what you're writing to, right? The output. So
sure.
You can reduce the amount that you're writing by using compression, then obviously things are going to go faster. Lightspeed, Idera has a product, Redgate has a product, a bunch of those. A bunch of others have products, and the Ola Hologren will plug into all of those, or most every one that I've experienced.
Okay, that's still kind of considered a SQL dump, though, with using those tools. Okay.
Typically, yes.
Okay.
Yeah. Okay. Great questions, particularly the question about how does this play into other. Why would you use SQL Server high availability when you've got other technologies like VMotion? Other questions? All right. As we wrap up, I think Chris is going to come back online. But as we wrap up, if you have a question that maybe came to mind after we disconnect from this webinar, feel free to shoot me an email. Always answer the questions. Be happy to talk with you on it if you'd like. But I certainly answer the questions. Just may take me a day or two, depending on where I am and what I'm doing, but be glad to answer whatever questions you may have.
Great. Thanks, Joe. And thanks, everyone, for joining us today for our presentation. As Joe mentioned, if we're unable to get your question or you happen to have another question that comes up after the fact, please feel free to reach out to us or Joe. We hope that you found this information beneficial, and we hope to see you again on our next webinar. Hope you guys have a great afternoon. Thank you so much.
you.